So Avantika, I'll just rush you through these basic numericals. These are class 9th level. They will just refresh your memory about, you know, what we will require in physics in motion in one dimension. So acceleration is a change in velocity upon the time interval in which the change in velocity has taken place. Any doubt about this? Avantika, any doubt? Okay. One thing that we need to understand whenever we are doing, wait, note रखते रहो. Whenever we're doing physics chemistry is this triangle is change, and change is also always given as a final minus initial. We will use this in chemistry also again and again. So please don't confuse this in chemistry as in physics. This is a symbol of delta. Change is always final minus initial. In chemistry, we will be doing this chapter rate of reaction. Rate of reaction. There again, a lot of confusion will come. Change is always final minus initial. So, for example, if I say delta P, this is change in pressure. So, change in pressure is final pressure minus initial pressure. If I say delta V, this is change in velocity. This would be final velocity minus initial velocity. If I say delta T, this would be final time minus initial time. Avantika, do we have any doubt about this?
No.
So delta is change, and change is always final minus initial. Now you might be thinking, why am I, spending so much time on this? For a simple reason that I am driving at 5 meter per second. Then I stop. When I stop, my final velocity is zero. So change in velocity would be final velocity minus initial velocity, and the change is negative. Have you understood what I said?
Yeah.
So that is why, at times what students do is they'll say change is 5 minus 0 is equal to 5. No, this is wrong.
Okay.
Change is always final minus initial.
Okay.
Somehow, the interaction that I have with students is somehow they think that change has to be positive. No, no. If I see how this will start making sense is, for example, I'm going at 5 meter per second, and then I increase my speed to 10 meter per second. Now
Hmm.
here the change is positive. Have you understood what I said?
Yeah.
Now, when we'll be doing chemistry, something
Hmm.
like this will happen that this is state 1,
Hmm.
this is state 1, and this is state 2.
Hmm.
So, in chemistry, we'll be doing these kind of numericals. Don't worry much about it now, but I just want to tell you. So, for example, the pressure actually in class ninth also, there is a chapter by the name of gas laws. If you remember, this was the last chapter in chemistry.
Hmm.
So, there you would have used so for example, the initial pressure is 1 atmosphere and the final pressure is zero point 0.5 atmosphere. 0.5 atmosphere.
Hmm.
So the change in pressure is final minus initial. Is final minus initial.
Hmm.
So it is 0.5 minus
Okay.
1 is equal to minus 0.5 atmosphere. Have you understood?
Yeah.
The change is always final minus initial. Always. In physics or in
Hmm.
chemistry. So for example, in this case, if the initial pressure was 1 atmosphere and the final pressure was 2 atmosphere, then the change is positive. It is 1 atmosphere. Is it making sense? Avantika, is it making sense?
Yeah.
Okay. Now let us come back to the basic definition that we were discussing here. So acceleration is delta v upon delta t. Delta v is change in velocity. So if it is change in velocity, it will be final velocity minus initial velocity. Any doubt?
No.
Now, this is the convention that is usually followed in physics, especially in motion, and especially in numericals regarding acceleration mechanics. U is the initial velocity, V is the final velocity, and you'll See a word written here t. Now this t is a time interval. So it is t, the time interval is t2 minus t1 upon t2 minus t1, which is equal to delta t. Is it making sense?
Yeah.
So basically, loosely, that what we say is that t is the time, but t is not the time. T is actually the time interval, which is equal to the final time minus initial time, which is delta
Okay.
t.
Okay.
So usually, when we in class ninth, when we write a numerical, we write it as v minus u upon t. But what we need to understand is, and understand it very clearly, that the t is the time interval. It is t2 minus t1.
Okay.
So, and another confusion that students usually have in acceleration is the unit of acceleration. About what do we mean by meter per second square? This meter per second square is also written as ms minus 2. So, usually students have a confusion about this also. So, we'll try to understand this. See, the numerator is v minus u. So, for example, this would be, let us assume, uh, 15 meter per second minus 5 meter per second. So my initial speed was 5 meter per second and my final speed is 15 meter per second. I'm calling it speed, but this is velocity. So let me correct myself. So the initial velocity is 5 meter per second and my final velocity is 15 meter per second. Are we clear?
Yeah.
So the change in velocity is a final minus initial. This is equal to 10 meter per second. Are we clear?
Yeah.
So this change in velocity has happened in 2 seconds. So the time interval that I am tracking is 2 seconds. Now see what will happen. If I do delta V upon delta T, what will happen is this would be 10 meter per second upon 2 second. So this would be 5. Are we okay till here?
Yeah.
Now let us examine this meter per second upon second. Let us examine this part where the confusion lies. Usually Usually kids get confused about this. Now you can see this is like this, that the numerator is meter per second.
Hmm.
The denominator is 1 upon second. Is it making sense?
Yeah.
So this would be equal to meter upon second square. मैडम आपको समझ आया? अवंतिका, any doubt?
No.
So that is why the units of acceleration is meter upon second square or meter second raised to power minus 2. Are we clear till here?
Yeah.
Okay. Now I'll do very basic numericals just to drive the concept forward. Velocity of an object increases at constant rate from 20 meter per second to 50 meter per second in 10 seconds. Find the acceleration. So simple, acceleration is delta v upon delta t. In this case, delta v is 30 meter per second and time is 10 seconds. So this would be 3 meter per second square. Avantika, any doubt?
Yeah. I'm sorry. No. Sorry. I understood.
No doubt, madam?
No.
Okay. So, okay. A pebble thrown vertically upward with an initial velocity 50 meter per second comes to stop in 5 seconds. Because it is thrown at 50 meter per second, so this pebble is thrown at 50 meter per second at its highest point. It comes to stop. So when it comes to stop, the final velocity will be 0 meter per second. Any doubt?
No.
Now again, what you need to see is, again what you need to understand very clearly is that the change in velocity is the final velocity minus initial. So the change in velocity is minus 50 meter per second. Is it making sense? Be very
Yes.
clear about this because a lot of things will follow after this. The time is 5 second. 5 second. So acceleration is minus 50 meter per second upon 5 second. This is equal to minus 10 meter per second square. Is it making sense?
Yeah.
Now, when acceleration is negative, what it implies is that this is a retardation. Are you clear?
So your voice got airy again.
Okay. So, because the acceleration is negative, This acceleration would be called retardation. Are we clear?
Yeah.
Now, another thing that we need to understand is that when the ball is thrown upward, when the ball is thrown upward,
Hmm.
the acceleration has to be negative because there would be an opposing force. There would be an opposing force which will try to slow down this, and this flow and this force which is acting would be opposite to the direction of the velocity of the stone. Are we clear?
Hmm.
So that is why when the acceleration is negative, that is why the force which would be acting on this stone would be in the negative direction, which implies that the force, as we understand, is due to the force of gravity and it is in the negative direction and it is opposing the motion of the stone. Are we clear?
Yeah.
So that is why we need to understand that the sign which is negative is implying that the force is negative, that the force which is being applied on the stone is opposing the motion of the stone, of the motion of the stone. Are we clear?
Yeah.
Again, basic numericals just to refresh our knowledge of acceleration. They are not very, they are not very high funda numericals. So start from rest. Whenever something starts from rest, it implies that the initial velocity is 0 meter per second, acquires a
Hmm.
velocity of 180 meter per second in 0.05 hours. Of course, the delta t is 0.05 hours, but what we need to understand is that because this is in meter per second, this 0.5 hours has to be converted into seconds. So half hour when converted into minutes is 30 minutes, and when converted to seconds is 30 into 60 is equal to 1800 second. Are we clear?
Yeah.
Good doubt, madam? 180 second. Zero, अच्छा 0.05 सोया हुआ तू भी सोया हुआ I'm sorry यार this is 0.05 hours ओ भाई सर आपको गलती निकालनी है मेरी so 5 upon 100 into 3600 second. So this is 6 5 the 30, 5 3 the 15, 180 second. Avantika, have you realized my mistake?
Yeah.
I had assumed that it was zero point 0.5 hour, but it
Yeah.
is 0.05 hour. So
Hmm.
delta V in this case is a final minus initial. So final is a 180 minus initial is 0. So delta V is 180 meter per second whole upon 180 second. So the acceleration would be 1 meter per second square. Are we clear?
Yeah.
So we have Miss Sambhavi Gupta sitting here. So she made me realize this mistake that I was doing.
Hmm.
Okay. So question number 11. A body is moving vertically upward, again upward, its velocity changes as constant rate. Constant rate. What this constant rate implies is that the acceleration is constant from 50 meter per second to 20 meter per second in 3 seconds. Is it making sense?
Hmm.
See, Avantika, because I'm trying to do these numericals on uh, both for class 9th and class 11th. See, what you need to do is, what we need to understand is that close to Earth, the acceleration due to gravity is constant. Have we understood?
Yeah.
But then in class 11th, we will be doing a chapter regarding gravity. And there we will do numericals where when we go far away from Earth, the acceleration due to gravity changes. Have we understood?
Hmm. Yeah.
So all these numericals which are that we are doing now, they will specify that the acceleration due to gravity is constant. So all these numericals are close to Earth. We haven't gone far away from the Earth. Are we clear?
Yeah.
And another thing that we have to be very clear is that all these are close to Earth, because if we start going, under the surface, again the acceleration due to gravity will start changing. Am I making sense?
Yeah.
So we'll be doing the changes in acceleration due to gravity at heights as well as in depths. So that is why I want to specify that in these simple numericals close to Earth, the acceleration due to gravity is constant and is usually taken as 9.8 meter per second square, or they specify that you can take this as 10 meter per second square. Is it clear?
Yeah.
मैडम आपको समझ आ पक्का? So let us come back to the numerical. Sorry. Yeah. So let us come back to the numerical. One second. So we come to this numerical again. Body is moving vertically upwards. Its velocity changes at a constant rate. Now, that is what I was trying to tell you, that this body is moving close to Earth. It is not very far away from Earth, and neither it is under the surface of the Earth. So that is why what they have mentioned is that the constant rate, the acceleration is constant from 50 meter to 20 meter per second in 3 seconds. So again, acceleration is delta v upon delta t. So this is v final minus v initial upon delta t, and it is 20 minus 50 upon 3. This would be equal to minus 30 upon 3, and this would be equal to minus 10 meter per second square. Avantika, is it making sense?
Yeah.
So this minus 10 meter per second square is the acceleration due to gravity. Basically, it is the retardation which is pointing in the downward direction. Are we clear?
Mm-hmm. Yeah.
If this body, rather than moving vertically upward, if this would have been following down, then it would be increasing its speed at a rate of 10 meter per second per second square. Is it making sense?
Yeah.
Now, because it is moving upwards, because it is moving upwards, because it is moving upwards, and because in this numerical, question number 11, what we have assumed is that the up is positive. That is why it is, when the acceleration had come, it is in the negative direction. Is it making sense?
Yeah.
See, what you need to understand is that because for class 11, this will be very important for you guys in class 10th, class 11th. See, when you say that this is 50 meter per second, and when you say that this is 20 meter per second, there is an assumption that you are making, and that assumption is that up is positive. Have you understood what I've said?
Yeah.
This is the assumption you have made. There is already an intrinsic assumption when you are doing the numerical that the upside is positive. Avantika ji, are we clear?
Yeah.
Okay. And that is what the textbook is saying, that minus 10 meter per second square, the negative shows that the velocity decreases with time. So retardation is 10 meter per second square. Are we clear?
Yeah.
Okay. Because see, we have to be very sensitive to these signs, positive and negative signs, so that we understand what is happening. Because depending upon the acceleration, our force will take the sign of the acceleration. So, for example, if acceleration is negative, then the force would also take the sign of the negative acceleration. Have you understood, Avantika?
Yeah.
Okay. And if you see these numericals closely, there is two kind of motion which is happening. Either the motion is happening up or down, or it would happen uh, right or left. And both these motions are called motion in one dimension. This is our physics chapter 2, class 11th. Is it making sense?
Yes.
So have we understood motion in one dimension?
Yeah.
Okay. Now if you see what they are saying, so for example, when you see this numerical, a toy car initially moving with a uniform velocity of 18 km per hour comes to stop in 2 seconds, find the retardation. So in this case, our movement is happening left right. So this is one dimension only. So up down is one dimension and left right is one dimension. Are we clear?
Yeah.
So uh, one of the tricks that we use is to convert kilometer per hour into meter per second. What we do is we multiply by 5 by 18. Are we clear?
Yeah.
So you can note this down. Convert kilometer per hour to meter per second by multiplying with 5 by 18. Are we clear, Avantika?
Yeah.
So this is the factor that we can use. Why we have to use this system? Because we follow the MKS system, where in physics we do all numerical in meter, kg, and second. Avantika, are we clear?
Yeah.
Okay.
Yeah.
So, toy car moving with the velocity 18 kilometer per hour. So, 18
Hmm.
kilometer per hour into 5 by 18 is 5 meter per second. Are we clear?
Yeah.
Comes to stop. So, this is the initial velocity. Comes to stop. So, this would be 0 meter per second in 2 seconds. So, delta t would be 2 seconds, and acceleration would be delta v upon delta t. This would be 0 minus 5 upon 2. This would be minus 2.5 meter per second square. Are we clear?
Yeah.
Great. So let us move on to the next numerical. One second. So car accelerates at a rate of 5 meter per second square. Find the increase in its velocity in 2 seconds. So now what they are asking is that acceleration is delta v upon delta t. It accelerates. So this is acceleration and increase in velocity in 2 seconds. In 2 seconds. So now they are asking us the delta v, and delta v would be equal to 10 meter per second. Avantika, any doubt?
No.
Okay. So next question 14th. Car is moving with a velocity 20 meter per second. Brakes are applied to retarded at the rate of 2 meter per second square. So this would be acceleration. And because it is retarding, this acceleration would be taken as negative. So acceleration would be minus 2 meter per second square. Avantika, any doubt?
No.
Madam, good doubt? Sir? Okay. What will be the velocity after 5 seconds after applying the brakes? So the formula that we have is the acceleration is retarding. So minus 2. We want the velocity after 5 seconds. So v minus u upon t 5. Sound good out? So this would be equal to minus 10 is equal to v minus 20. So v would be equal to 10 meter per second. So after 2 seconds, this 20 meter per second will reduce to 10 meter per second. Avantika, any doubt?
No.
Okay, great. So these are very basic numericals.
Hmm.
If you are not clear, you can practice them. This will refresh your class 9 fundamentals. So
Okay.
accelerates 2 meter per second square, bicycle moving with a velocity of 5 meter per second accelerates at the rate of, so what would be the final velocity? So final velocity is v, it was moving at 5 meter per second and the time is 5 second. So my v would be 5 into 2, 10 plus 5, this 5. So my v would be 15 meter per second. Avantika, any doubt?
No.
Sanji, good doubt? Okay. Now this is the final numerical. Car is moving in straight line, one dimension with a speed of 18 kilometer per hour. We know this is 18 into 5 by 18 meter per second. So this would be 5 meter per second. It is stopped in 5 seconds by applying the brake. Find the speed of the car in meter per second. So the uh, see moving with the speed of this. So this would be my u. It is stopped in 5 seconds. This would be my t, and
Hmm.
I want the Acha, the first part is speed in meter per second. So the first part is 5 meter per second. This is my answer for 5 meter per second. This is my answer for the first part. The retardation is equal to v minus u upon t.
Hmm.
So it is stopped. Because it is stopped, therefore my final velocity would be equal to 0 meter per second. So this would be
Hmm.
minus u upon t. My t is 5, so this would be minus 1 meter per second square. Any doubt?
No.
The speed of the car after 2 seconds of applying the brake. See, now
Hmm.
what we need to understand is that the retardation that we have to take, the retardation that we need to take would be the constant retardation of 1 meter per second square. Is there any doubt?
No.
See, what has happened to the car is that the car was traveling at 5 meter per second. It took
Hmm.
it took 5 seconds to come at to stop. Now what he is asking you is what is the speed after 2 seconds? So 2 seconds would lie somewhere here. But
Hmm.
throughout this journey of 5 seconds, the constant retardation of minus 1 meter per second square has to be taken. Have you understood what I said?
Yeah. Yeah.
So acceleration is v minus u upon t. Acceleration is minus 1 is equal to this v that I am taking now is this v which happens after 2 seconds. Are we clear?
Yeah.
भाई शिवांग कुछ समझ आ रहा है नहीं आ रहा पक्का so v minus u is 5 whole upon because this is 2 seconds this would be 2 so my v would be equal to minus 2 plus 5 and my v would be 3 meter per second. Is it making sense?
Yeah.
So this is what has happened to the car. It was at 5 meter per second. After 5 seconds, see from here to here is 5 seconds. Here the speed is 5 meter per second. But after 2 seconds, here to here is 2 seconds. After 2 seconds, it is at 3 meter per second. Is it making sense?
Yeah.
But what you need to understand is that throughout these 5 seconds, the retardation is constant of minus 1 meter per second square. This acceleration or the retardation is constant. Please understand that.
Okay.
The acceleration is the acceleration is constant.
Hmm.
Any doubt?
No.
Constant constant acceleration. And that is what I was trying to tell you here. That when we take the example of Earth, close to Earth, the value of g is constant. It is a case of constant acceleration or retardation. But
Hmm.
when you go far away from Earth, so for example, if you are say, if you are sending a satellite to Mars, throughout this journey, the acceleration will change. Are we clear?
Yeah.
And then when we go in space, then we'll have to take care of all kind of acceleration, net acceleration. There would be acceleration due to effect of sun. There will be acceleration due to effect of Jupiter, and all kind of nonsense would be happening.
Mm-hmm.
And that is why they call it rocket science. Are we